Okay, let's take a look at how to solve some problems now. I'm going to show you two ways of doing this. The first way is a little bit more involved, but what's going on, the way that we're solving the problem is very clear. I'm going to show you in another video a way to solve this that involves some shortcuts, but it's a little bit harder to understand the math that's going on behind the scenes. When I'm going to ask you to do a problem on an exam, chances are you're going to want to use the shortcut method, but I think it's important to understand what's going on here. So let's remember, first of all, where we're headed. We want to get an F statistic. And the F statistic, of course, as you know, is the ratio between the mean square between and the mean square within values. And this, in turn, the mean square between is equal to the sum of squares between divided by the appropriate degrees of freedom between, and the mean square within is the sum of squares within divided by the appropriate degrees of freedom for the within sum of squares. All right, let's first just jot down some variables that we're going to need, and let's define some variables up front so we don't have to do that as we go. First, I'm going to use n to stand for the total n, all the subjects in the study in all the groups combined. Small n is going to stand for the number of subjects in each group. K is going to stand for the number of groups. It should be obvious that k times n is going to equal, k times little n is going to equal capital N. G is going to stand for the grand mean. The grand mean is the mean of all the observations in all the groups taken together. Each individual group will have its own group mean. We don't need any notation for that. T we're going to use later on. We'll define it here. T is the total score in each group. Okay, now we can tuck into a problem. Let's suppose that we have a new program designed to improve reading comprehension. We have three groups, Group A, Group B, and Group C. Group A is a control group. They just read some passages and are asked to answer some questions about those passages. Group B has to write questions and then also answer those questions. And Group C, same as Group B, but they have to write more questions. And we're interested in finding out their level of reading comprehension 1 week after they've completed this training. All right, here's what the data looks like. Remember, we're trying to find an F ratio. We need a mean square between and a mean square within. To get those two mean squares, we need sums of squares. So that's the first thing we need to do. All right, so of course you remember that the sum of squares formula is written like so. It's going to be each x minus x bar squared. And I'm going to label this x bar 1, xa for the sum of squares for group A, and this as x bar A for the mean for A. I've already gone ahead and figured out these means. This one is 5, this one is 9, and this one is 10. So let's do our first sum of squares. That's going to be 2 minus 5 is negative 3. Square that, we're going to get a 9. The next one, 3 over here, minus 5 is negative 2. Square that, we're going to get a 4. Next one is a 6. Next one is an 8. 8 minus 5 is 3. Square that, we're going to get a 9. And then I'll just fill the rest of these in. A 1, a 0, and a 1. All right. Now let's do the same thing for our Group B participants. X bar B minus xb minus x bar b squared. Our x bar value is 9 over here. So the first one is 5 minus 9, which is negative 4. Square that, we're going to get 16. Next one is 9 minus 9, 0. Square that, we're going to get 0. 9 minus 1 is, we have a 9 minus 1. What do we have here? Sorry, 10 minus 9 is 1. Square that, we get a 1. Next one is 16 and a 1 and another 0. And then finally, we'll do this with group C. xc minus x bar c squared. And I'm just going to fill this in really quickly. 4, 16, 4, 1, 1, and a 4. Now, we're interested in the sum of squared differences. So let's add these up. 24, that is 16 plus 1 is 17, plus 16 is 33, plus 1 is 34. And 4 plus 16 is 20, plus 4 is 24, plus 25, 26, and 30. All right. So these sums of squares represent our sum of squares within each separate group. And we want to add these together, and we're going to get 88. So our value for sum of squares within is 88. All right. The next thing that we want to do, remembering our formula that the total sum of squares equals sum of squares within plus the sum of squares between, figuring out the sum of squares between using this table method here is not something that's possible to do. There's a formula that you can use, and I'll show you the formula later. But instead, we do need this sum of squares between. What we're going to do is we're going to calculate the sum of squares total and then subtract sum of squares within from sum of squares total in order to get sum of squares between. All right. So to do that operation, to get that sum of squares total, what we're going to do is something similar to what we've done up here in this first part, but instead of using each group mean, we're going to use the grand mean. We're going to use the mean from all of these scores, and we're going to subtract those from the grand mean. The grand mean is easy enough to compute. Simply add up all the scores, divide by the number of scores. There are 18. And I can tell you, because I've done it already, the grand mean equals 8. Okay, so what does this look like? We're going to take each XA first and subtract it from the grand mean. And I'm going to put a G there, and we're going to square that. So for the first one, we have 2 minus the grand mean is 8. That's going to give us 6. 6 squared is 36. And the next one is going to be 3 minus 8 is 5, negative 5. Square that, we're going to get 25. The next value is 8 in there. 8 minus 8 is 0. Square that, we get a 0. The next value that we have is 6. 6 minus 8 is 2. Square that, we get a 4. Next value we have is 5. 5 minus 8 is negative 3. Square that, we get a 9. And finally, the last value is a 6. 6 minus 8 is negative 2. Square that, and we get a 4. And I'm just going to fill these in here really quickly for the other values, doing the same thing. And that's going to give me a 9, 1, 4, 25, 0, and a 1. All right, now we're going to add up each of these. And this is going to come out, after we add them all up, to 172. So our total sum of squares is 172. Let's recap where we're at. Sum of squares within equals, what was it? 88. Total sum of squares equals 172. Therefore, our between sum of squares is 172 minus 88, which equals 84. All right, we're making progress here. Let's figure out now our degrees of freedom. The degrees of freedom within equals n, which is 18, minus k, which is 3. Degrees of freedom within is 15. Our between degrees of freedom is k minus 1. We have 3 groups. Minus 1, we have a 2. And we don't need the total sum of squares for anything, but let's put it in there anyway. That is capital N, all of the values, minus 1. We have 18 values. 18 minus 1 is 7. All right. So the mean square between is equal to 84 over 2. That's this 84 divided by this 2. And that is going to equal 42. The mean square within is going to be 88 divided by 15, and that equals 5.867. All right, our F ratio finally, after all that, is MSB over MSW, and that is going to look like this: 42 over 5.867, and that equals 7.159. All right, now we have to take a look at the F table and figure out the critical value. It was difficult to use the F table in your textbook, just didn't come across well in a screen capture, so I found this one on the internet, but they all pretty much work the same way, and I will say they work a bit differently than the ones we used for the Z and the T distribution. With the F distribution, we have two kinds of degrees of freedom. We have degrees of freedom in the numerator, or the degrees of freedom for the mean square between, and the degrees of freedom in the denominator, or the mean square within. So the way that we use a table like this is generally the column is for the mean square between, and the row values are for the mean square within. So we have, scroll up here, the mean square between the degrees of freedom is going to be 2, and the mean square within degrees of freedom is going to be 15. So we're going to move down this 2 column until we get to 15 over here. And that intersection is going to give us our critical value. In this case, critical value for F with 2 and 15 degrees of freedom is 3.6823. So our calculated value was 7.159. So we would reject the null hypothesis that these means were equal. It's worth pointing out that this critical value is for alpha equals 0.05. Because of the way these tables are set up, we need a different table for different alpha levels, but no worries there. I'm only going to be asking you for critical values where alpha equals 0.05, so the basic table will be the one that you can work with. Okay, so that's how you solve an analysis of variance problem. In the next video, I'm going to show you 1 or 2 shortcut methods that don't require you figure out all of these sums of squares manually. And we'll take a look at those in the next video.